Okay, so in this demonstration we're going to cover how to define datum features and ultimately establish a datum reference frame. That's going to include identifying our datum features, primary, secondary, and tertiary, qualifying them, and then ultimately adding a datum feature symbol to label them and give them a name. We're going to use the whole bar example here, and you can see how it mates in the assembly. It's this back face. So the back face of the whole bar is going to mate up against that. That's a good candidate for our primary datum feature. It's also going to mate up against this block on the bottom face, which would be a good candidate for our secondary feature, datum feature, and then ultimately our third tertiary datum feature is this face over here on the left that's pushed up against this surface. Let's go ahead and switch over to Creo and demonstrate how this can be accomplished. So what I have here is the finished result. If you look at datum or the 04 datum reference frame combination state, it's in an orientation that I can see all three datum features. So if I do a semantic query, I can pick on each of the feature control frames and the labels and see that they're associated to the relevant model geometry. So let's go ahead and recreate what you see here on the screen. First thing we need to do is qualify this primary datum feature, which is this flat face here. So I need to pick an appropriate annotation plane. In this case, I'm going to use the left plane. Right? So the black arrow indicates which direction is the viewing direction, and then the red arrow indicates the direction of the text. So let's qualify this feature by adding a geometric tolerance. And I'm going to place that feature control frame on this surface, say right here. So I left click and select the surface, and then I middle click and place it. Right, now this is not a true position tolerance that we're going to use to qualify this. We're going to use a flatness geometric characteristic, and I want that to be within a 5,000ths tolerance zone. And that's it. So we've now qualified that feature. So the next thing we need to do is give it a name. So we use the datum feature symbol here, and we can simply select on that feature control frame and then middle click to place it. And it starts with the letter A. So the only thing we need to do now, just to meet all of your ASME and standards rules for associating geometry to maximize downstream reusability and interpretation, I want to associate that surface to the datum feature symbol as well. Go ahead and click OK. If I want, I can move this a little bit better so that the A is out in space and not overlapping with the model. So let's do the same thing for datum feature B. In this example, I'm going to use the bottom view, the bottom annotation plane. So I'm also going to create a geometric characteristic attached to that surface. Right? This is not a flatness tolerance, but it is a perpendicularity tolerance that we are desiring here. Right? You can see if I zoom in on this, there's like a little red line underneath that text. Yeah, it's kind of like Creo's version of spell check in Word. It's telling me it's not right. There's something missing, and what's missing is a datum reference. So we're going to type in the letter A there to complete the definition of that. My red line went away. I can left click in the background, and I've finished qualifying datum feature B. Next, I just need to give it a name. So I'm going to attach that datum feature symbol right to the feature control frame, and come over here to the references and attach those references. For the tertiary, I'm going to add a geometric tolerance feature control frame attached to that surface. Middle click to place it. And this one is not only required to be perpendicular to datum feature A, but also to datum feature B. And we now have fully defined our three datum features.